Hello, I welcome you to this tutorial. Here we'll be looking at the concept of mean median mode for grouped data. In one of our previous classes, we've discussed for group data. So by the end of this tutorial, you should be able to calculate the mean, median, and mode for grouped data. You should also be able to estimate the mode from histogram. I am your mathematics tutor, Ademola Folarin. This tutorial is powered by IOTA Virtual Learning. So let's learn together. Recall the concept of mean. The mean is the average score for a given set of data or set of score. So the mean is always calculated by saying the summation of the frequency and the score. That is, frequency and score for each, the total sum of it, or divided by the total sum of the score given to you. That is for the mean. For median, recall we've learned that median is a middle number when the given set of data is rearranged. But because we are dealing with grouped data, it follows a special formula, which is the lower class boundary of the median class plus, open bracket, the total number of score, that is the total frequency n divided by 2, minus the cumulative frequency before the median class, divided by the frequency of the median class, all multiplied by the class size. So this is the lower class boundary of the median class. The n stands for total frequency of the data set. The CFB stands for the cumulative frequency before the median class, while the FM here stands for the frequency of the median class, and C is the class size. Remember, if the class size is 20 to 29, 30 to 39. So to determine the class size for this given size, the class size C will be equals to, you are going to look at the how many value is covered here. So you can from 20, you start from 20, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and that is 10. So the class size is 10. Don't make mistake of saying you just start from counting 21, 22. No, you start from the 20, which is the lower limit, to the upper limit. The total value there that is captured is the class size. Now that we know this, the mode for group data also has its own special formula. The mode is the lower class boundary of the mode, the lower class boundary of the modal class, let's put it that way, plus, open bracket, the frequency of the modal class minus the frequency before the modal class. This is the frequency of the modal class, divided by the frequency of the modal class minus frequency before, all in bracket, plus the frequency of the modal class minus frequency after, that is the frequency after the modal class, all closed, multiplied by the class size. So oftentimes, to make students find interest in this, I advise students that instead of using this that may want to look confusing, you can understand one thing, that do it this way. Delta 1 is the frequency of the modal class minus frequency before. Make delta 2 to be frequency of the modal class minus frequency after. So if you can do this, that means this formula can then be converted to something of this nature. saying L plus delta 1 over delta 1 plus delta 2, all multiplied by the class size. So it's either you use this or you use this. Any of the two you can use to calculate the mode for a grouped data. Now we understand this, let's move further to take a comprehensive question, a standard WAEC question as such. Take a look at this. We are given this table below, then we are asked to draw the histogram. Remember, for you to draw the histogram, you have to draw the frequency against the class boundary. For histogram, you are going to be plotting frequency against the class boundary, which means we need to extend this table to determine class boundary. Also, we are going to be calculating mean, median, and the modal age. So we are going to prepare a frequency distribution table that is more detailed than this. A frequency distribution table that is more detailed than this. So in order to do that now, let's extend this table. So we'll do more of this table. The column that we are going to be needing. So we need the column for class mark, that is the class mid mark. Also, we need the column for the product of frequency and the score. The product of frequency and class mark, that's fx. We need column for that. We also need column for the class boundary. So we can say we need that up to this point. I think with that, also we need column for the cumulative frequency. So we can have that one here. Now, let's move ahead. Let's quickly label all this so that it can be easier for us. This one, score, that is the mid value, x. We need this one as fx. We need this one as cumulative frequency. And we need this one as class boundaries. Class boundaries. Interesting. So let's quickly look at it. Here, how do we get the score, the mid value? What we need to do to get the mid value is to plus 21 with 25. That gives us 46. Then we divide it by 2. That will give us 23. 23. Right? So if we do the same here, 26 plus 30, we divide that by 2. That gives us 28. And we do the same all through. This gives us 33. And this gives us 38. This gives us 43. And this gives us 48. Now that that is known, we then move forward to having the product of frequency and score. We look for the product of frequency and the score, which is going to be multiplying this with this. That's 161. You do the other one, that gives us 308. We do this, 99 multiplied by 3, that's 297. Also 9 multiplied by 38, we get 342. We multiply 6 by 43, that was 258. Then lastly, we multiply 8 by 48, that gives us 384. Now that we've done that, what is left is to find the total. We then find the total of it. So we add up all this fx. So you realize that when you add the fx together, you should get something. What do we get? Upon adding it together, we have 1750, 1750, 1750, 1750. That's fx. So we can keep that. We are going to be using that to calculate the mean. Now that we've gotten that, let's do addition of the cumulative frequency. Recall that the cumulative frequency is obtained by saying this is the first frequency, 7 plus 11, that's 18, 18 plus 9, that's 27, 27 plus 9, that's 36, 36 plus 6, that's 42, 42 plus 8, that's 50. So which meets up with this? Can use that to confirm that total frequency is 50. Then we move to the class boundary. To determine the class boundary, recall, you subtract 0.5 from the lower limit and you add 0.5 to the upper limit of the class interval. So doing so, removing 0.5 from this 21, it gives us 20.5. Add 0.5 to the upper limit, it gives us 25.5. Do the same to the following class intervals. So here, remember the last of these start this. So this is 25.5 to 30.5, then 30.5 to 35.5. So for this class, 35.5 to 40.5. Then for the 41, we have 40.5 to 45.5. And lastly, that's 45.5 to 50.5. Now the class boundary is structured out. So the frequency here, the total frequency is 50, which also can be checked using the cumulative frequency. Now that this is known, we can then move to plotting our graph. We'll bring in our graph. We'll be plotting the frequency against the class boundary. Plotting frequency against the class boundary. So we'll draw the graph. Let's make it this way. Plotting this. So let me quickly label that. Now, at this point, which is the class boundary, CB, class boundary, here stands for the frequency F. So what is the frequency is from what we have here. We are plotting the frequency with the class boundary. So the frequency highest is 12. Highest is 11. The lowest is 6. So what if I decide to make it 2, 2? So here, 2, 4, 6, 8, 10, 12, 14. And here, the first in this class, I want to use is 20.5. So 20.5 is the lowest here. I'll start from the class by 20.5. So you can make this one 20.5. Let me start from here. 20.5. 20.5. Then followed by the next class boundary, which is 25.5, followed by 30.5, 35.5, 40.5, 45.5, 50.5. Now let's look at one thing. Students often make mistake since this class boundary did not start from 0, which means from here to here from here to here cannot be said to be 20.5, and from here to here is 25.5. What we have represented here is that each of these boxes is 5.5, and I did not start from here. So we give the sign of extrapolation. Always learn that. Doing this shows that I've compressed some value behind here. So I'm covered now to say each of these boxes is 5.5. Now that that has been done, let me now plot the graph. The very first one goes to frequency of 7. So frequency of 7, we go to where 7 is between 8 and this. So 7, which is to be here, frequency of 7, we do this. Remember, that's the first class boundary. That's frequency 7. The next has frequency 11. So go to where frequency 11 is in between this. 1, 2, 1, 2, 1, 2. So 11 is here. Put it here. That's 25 to 30.5. The next is 9. The 9 is in between 8 and 10. We do that. The next is also 9. So they are together. And followed by 6. The next is 6 here. So this is how we prepare histogram. And lastly, 8. So this is how we prepare histogram. Remember, histogram is used to represent data when we are dealing with group data. It's a graph for group data. Now that we've done this, the question says from the histogram we should estimate our mode. We have answered A, but to estimate the mode from the histogram, that is the next thing. Estimate the mode from the histogram. To do that, you look at the highest, you make a dotted line on the highest part. From this edge to this edge, you draw a dotted line that we can see. Okay. I'm not going to be making it dotted so that all of us can see, but it's always dotted. That's why I'm using another color. So you also do the same thing in this diagonal, because this is the modal class. This is the modal class. The most occurring class is in that way. Now you go to where this meets, you trace it down. We are estimating. That's why the question is always estimate, but you must try as much as possible to make it right. You are estimating. So here now is where we have the mode. Here is where we have the mode. So if we are answering that now, the question says we should estimate the mode. B, we are estimating the mode from the class by the estimation of the mode. Let's say estimated mode equals. So if I look at this, since each of these boxes, each of these big box is 5.5. So if I look at it, the 5.5 divided by 5 to make it easier for you, that's like saying 1.1. So 1.1, 1.2, 1.3. So we can say it's about 1.35. 1.35. Now here, add that 1.35 to the lower boundary. So if I add that 1.35 to the lower boundary here, so 3.35. Let's start again. Remember that each of the tiny boxes here is 1.1. So if I say 1.1, this is with another one, 2.2, this is 3.35 is in the middle. So the 3.35 to be added to this one, that's 25.5 plus 3.35. You know the 3.35 is the lower boundary of the modal class. So when I add this together, this one can give me around 28.85. So I can say approximately the mode is 29 years. So that's the age of the worker there, 29 years. If we are not mistaken, 29 years. So we've been able to estimate the mode to be 29. It's interesting, right? So next we move on to calculating the mean, the median, and the mode. To calculate the mean, the median, and the mode. So here, dealing with the mean, that's number one. The mean, recall that the mean has the formula summation fx over summation f, and that gives us the summation fx is what we have here, which is 1750 divided by 50, which is the frequency, and that gives us 35. X, which is the mean, is equals to 35 years. That's 35 years for the mean. So the next thing is the median. Median equals, recall the formula. We say the median is L plus the number over 2 minus cumulative frequency before divided by frequency of the median, all multiplied by the class size C. So let's take note. The median class is the middle. So here we have total number of workers to be 50. So the middle of it is going to be 25. So using our cumulative frequency, you can see that this is where that falls. So here is the median class. Here is the median class. This is the median class. So what is the lower class boundary of the median class? The lower class boundary of the median class is 30.5. So we do 30.5. That's the lower class boundary, plus total frequency is 50 divided by 2. Now, cumulative frequency before the median class, when you look at the cumulative frequency before the median class, is 18. The cumulative frequency before the median class is 18. So I will do 18 all divided by the frequency of the median class. Frequency of the median class, which is 9. Close the bracket. So the class size, I've told us the class size is always from the lower limit to the upper limit. So you count 21, 22, 23, 24, 25. So that is 5. That is 5. 21. So that's 5. Now we quickly do this. That becomes 30.5 plus, here we have 25. 25 minus 18, that's 7. So we have 7 over 9, all multiplied by 5. So that gives us 30.5 plus, so here we can say 7 times 5, which is 35 divided by 9, that's 3.888. So 3.88. When you do this, you add it together, 3.88 plus 30.5, which is the lower class boundary. So the median is equals to 34.38 28, so which is approximately 34. The median is approximately 34. We've done the median. The next for us is the mode. The next is the mode. So to do the mode, recall we have established that the mode equals the lower boundary of the modal class plus change in frequency before the modal class and the frequency of the modal class, delta 1 over delta 1 plus delta 2, all multiplied by the class size. So to make it easy, let's first say delta 1 is you subtract the frequency before from the frequency after. That is what we do. We must learn to do that. And how does that? Following this, if we look at it, before and after, you can even pick that from here. So now that we understand that, we move further to say the modal class is this. This place is the modal class because that's where we have the highest frequency. Now the difference between these, that's 11 minus 7, that gives us 4. Delta 2, which is the difference between this and this, that's 11 minus 9, that gives us 2. Remember that this is the modal class, so the lower class boundary here will be 25.5. That will be 25.5 plus 4, which is our delta 1, over 4 plus 2, and our class size is 5. So going by that, we have it to be 25.5 plus, we look at this, that's 4 over 6 to be multiplied by 5. So doing so, this becomes 25.5 plus 20 over 6. That gives us 3.33. And when we add these together, that gives us 28.83. And we can approximate it, the mode, to be 29 years. 29 years. Now the question asks us to compare the mode that we estimated with the calculated mode. For calculated mode, we have it to be 29 years. Before approximation, that's 28.83 years. That's our calculated mode. Let's now look at what our estimated mode gives us. Our estimated mode is also 28.85, approximately 29 years. You can now see how close it is. Both estimated mode and calculated mode, they are so close. It shows that we are on the right track. And this is how we calculate the mean, median, and the mode for grouped data. If you enjoyed this class, don't forget to subscribe to our channel. Also click on the like button for more educational videos like this. Till I come your way next time, I am your mathematics tutor, Ademola Folari. Keep learning mathematics.